Okay, so basically these are the workout solutions for the review we went over in class today. So basically, you're using area equals 1/2 AB sine C to get the angle, but if they don't make sure you pick the right angle. For example, in this problem, they give you the two sides, but they don't give you the angle between them. You need to be able to figure that out, and the concept is angles of a triangle add up to 180. So that's 2x and 1x. 2x plus 1x is 3x. 3x plus 72 equals 180. Subtract the 72, you get 108. X equals 36. Then you plug it back in. That would be 72 if you needed it. That would be 36. That's the one we need because that's between the two sides. So it'd be 1/2 product of the two sides, which is 11.8, 12.3 times the sine of 36. When I do all that multiplication, it's 42.7. Now the second one we did is find x and y in the diagram below. So x is the angle, y is the side. All right. I would basically look to find the angle first because that's going to be the more prominent way of doing the problem. All right. Basically, what we're looking at is they give you the 50, they give you the 8.5, so we use that sine 50 over 8.5, and then f is one of the angles we're trying to get, because that's the x, over the 9.7. 9.7 sine 50 divided by 8.5 gives us sine f equals 0.8742. Don't forget, we then go to the graph, for the calculator, do second sine, 0.8742, and that gives us 61 degrees. Triangle angle sum then allows us to get angle E, which is 69 degrees. 69 and 61 is 130. 130 plus 50 is 180. Boom. Now I can go back and get y, which is 69. So sine of 50 over the 8.5, you can use the same ratio, is sine of 69, which is the angle I found over y. I'm going to cross multiply 8.5 sine 69. Divide that by sine 50, and we get 10.4. Okay. On the top of the next page, in both diagrams below, Stewart can prove the triangles are congruent. What's the difference in their proofs? All right, in the one on the left, all right, both of them have the shared side, both of them have the right angle. The one on the left, the sides are the legs. So without using anything else, that would be side angle side. However, with this one, because it's the hypotenuses, and then the one leg would be hypotenuse leg. So make sure you know that difference before starting the quiz on Monday. And then finally, the last one was the proof we went over. All right, first off, you need to change HI congruent to IK. You got to change that to GH is congruent to GK. So GH is congruent to GK, angle 1 is congruent to angle 2. Now remember, to use hypotenuse leg, we need right angles. If 1 and 2 are congruent and they form a linear pair, they must be right angles. Angles forming a linear pair, congruent angles forming a linear pair must be right angles. All right, then we're going to use IG is congruent to IG, reflexive to shared side. Okay, so now these are right angles, all right, and then we got the hypotenuse leg. So the triangles are congruent by hypotenuse leg. Now, J isn't in that triangle, J is over here. So we have to use the parts of that triangle for that. So that gives us HI is congruent to IK by CP. Now, these two angles, you can, all right, if you want, show that they're right angles. Okay, but it's possible. However, all we need to know is that these are congruent. Okay? Hij is congruent to Kij because they form what? Linear pairs with congruent angles. Linear pairs are supplementary. So those angles are going to be congruent by the congruent supplement theorem. We then throw in Ij is congruent to Ij by the reflexive property. Hij is congruent to Kij by side angle side. All right. We want to prove JG bisects angle J, so we need to say that these two angles are congruent. HJI is congruent to KJI. That, of course, as always, is our CPCPC. And then we clearly state JG bisects angle J. All right, so that covers all those problems. Hope it helps. Good luck. Good luck studying, and we'll see you Monday for the quiz.